So our goal today is going to be to convert between radians and degrees, find arc length, which you probably talked about in geometry, and to solve problems involving angular speed. So this is also going to show you, you know your calculator, the default is radians. It's because from here on out in your mathematical life, radians are the boss. They're awesome. And so those are our default mode of operation. So when we're looking at trig functions, let's look at what we're talking about for input and output. What we have here, where I normally have an x, is theta, which represents an angle. And then what I get out is a ratio, which is a real number. So for a trigonometric function, the input variable is an angle, output variable is a real number, specifically a ratio. And when we talked about domain and range, domain is your input, so that means the domain of a trig function is an angle. And the range is the output, which we said is a real number or ratio. Degree units are an example of angular unit of measure. Realistically, what we want to work in is a linear measure, something like feet or inches or centimeters, meters. Any of those are things that we typically measure in if you think about like application type problems. So we need a way to be able to connect angular, like degrees, and linear. And what we use to connect those is something from geometry, arc length, which is basically like a piece of a circle, or like the crust of your pizza. So if I have my circle, arc length is saying if I have, and we always go from the positive x-axis, if I go a certain angle, how much pizza crust do I have? What do I have for my piece of my circumference? And what that linear measure that we're going to use is called a radian. So it's just way more useful in real life to talk about radians. And that's where we used like our piece of string and put that on the radius, measured that, and then went around part of our circle before break. And we can build this connection by using the radius of its circle and connecting to its arc length. Once again, we're just kind of putting in mathy terms what we already explored. So let's define a couple terms. The central angle of a circle has measure 1 radian if it intercepts an arc with the same length as its radius. What am I saying? So a central angle, back from geometry, means that the vertex of the angle is at the center. And in pre-cal and on, we are going to start with one part of my central angle is always on the positive x-axis. In geometry, it could kind of be anywhere. So what we did in our example is we took something that was the length of 1 radius and we put it along the circumference of my circle. And what we're saying is this angle is 1 radian. So 1 radian is when my arc length, the crust, is equal to the radius of the circle. And you may remember from before, the letter we use to denote arc length is S. That will come up in a second. So once again, recapping with some numbers, what we talked about. How many radians are in a circle? 2 pi. How many degrees? 360 degrees. What is the circumference? Twinkle, twinkle, little star, circumference equals 2 pi r. If we use a radius of 1, we have 2 pi times 1, which just gives me 2 pi. So our whole unit circle has 2 pi radians. So let's recap our visualization we've talked about. So we always start on our positive x-axis. That would be 0 degrees rotation or 0 radians. Notice I don't have a unit for radians. I don't denote anything. It's understood if I don't put something. And then all the way around my circle is a total of 360 degrees, or 2 pi radians. So if all the way is 360, half the way is 180 degrees, which you know that, a straight line is 180 degrees, and half of 2 pi would be pi. Then I can split stuff up more. I can split it up into fourths, so that would be 90 degrees, or 1/2 pi, or pi over 2. Then I could do 270 degrees, which is the same thing as 3/2 pi, or 3 pi over 2. You see both of those. Now I'm going to split that in half. So if I split that in half, I would get this angle is 45 degrees. I'm going to split that into half, and that would be pi over 4. Or you can think, if I go over here to pi, wow, that was really bad. Pretend those are the same. I'm dividing now this pi into 4 pieces. So this would be 1 pi over 4, 2 pi over 4, so that makes this one 3 pi over 4, or 135 degrees. And then 4 pi over 4, let's just keep going, 5 pi over 4, and that would give me 225. 6 pi over 4, that's the same thing as 3 pi over 2, and 7 pi over 4, or 315 degrees, going in groups of 45 degrees. And then I could do the exact same thing and go around in terms of 30 degrees, but we'll save that for a later day. So I said originally what our first goal was to be able to go from degrees to radians and radians to degrees. This is the same exact idea as back in the day when you would want to convert feet to inches. So say I have 2 feet. How many inches is that? That would be 24 inches. Let's put that in a little bit more of a structured form. I would have 2 feet, and now I'm going to multiply by something called a conversion factor. I need feet to be in the denominator so that my units of feet can cancel. So I need feet in the denominator so that they will cancel, and I'm trying to change to inches, which I can do directly. And my conversion factor is that 1 foot is equal to 12 inches, and then I multiply across, and I get that 2 feet is equal to 24 inches. You might be doing this in chemistry called dimensional analysis. This is exactly the same thing that you have done before to convert units, but now we're talking about degrees and radians. So I need my conversion factor. Now, we said on the previous page, all the way around is 360 degrees, or 2 pi. So we could say that 360 degrees is the same thing as 2 pi radians, but that reduces a little bit. So I could say that 180 degrees is the same thing as pi radians, and it doesn't matter which way I have my fraction. I could also have pi radians is the same as 180 degrees. I'll use one of those two things to help me. So if I want to do something like how many radians are in 60 degrees, you always start with what you're given. So 60 degrees, put that over 1. I need my degrees to cancel. So if the degrees are already in the top, I need to move them to the bottom. And then I think about my conversion factor. So 180 degrees is equal to pi radians, multiply across, so I get 60 pi over 180. My degrees have canceled. My units canceled. And so I get, that reduces to pi over 3. I just divided each of these by 60. Let's look at another one. Convert from radians to degrees. So notice right here, not just because I have pi, but because I don't have a degree symbol. That's why it's radians. So I have pi over 12 times, well, I have radians, which means in the denominator, I need to have radians. So that would be pi radians, and in the numerator, I need to have my degrees. Pi radians is equal to 180 degrees. So I get 180 degrees over 12, because what happens with these pies, wasn't that nice they canceled? Do they always cancel? No, no, no. So don't assume that degrees mean I don't have pies and radians mean I do have pies. That is not true. All right, so if I simplify this, I am going to simplify in 2 steps. You need to be able to do this without calculator. So I see these are divisible by 6. Oh, look, I can still divide. So no calculators on these steps.